This example is in a slightly different theme, and so I generally recommend people do this one out of order at the end because it doesn't have the pattern that we've been training you to look for, where you have one expression and then its derivative sitting outside. That's not the case here. The derivative of x plus 1 is not anything like 20x. But there is a way a substitution can help us with this. If you start out with, you might be thinking u equals x plus 1, and I agree that's probably the best choice. Can that help us at all with this integral? Well, if we do du here, we get dx. So let's see what we can cover here. The x plus 1, this, we can replace with u. The dx we can replace with du. So far, so good. We have our square root here, and we have this 20x is the part that we have not covered yet. But there's a way that we can still use the substitution here. X, if we take this expression and just subtract 1 from each side of it, we get u minus 1 equals x. So we have to make a little tweak, but we can replace that x with u minus 1. Let's do that and see if it actually helps. Our new integral is going to be 20. I'm going to kick that outside because I can. X gets replaced with u minus 1. The square root of x plus 1 gets replaced with the square root of u, or u to the half. And then dx gets replaced with du. Now this is better because we can take this u to the half and distribute it through the brackets, and we get 20 times the integral of u to the 3 over 2 minus u to the half du. And now the power rule can help. We get 20 times, let's see, increase this power by 1, divide by the new power, minus increase that power by 1, divide by the new power, meaning multiply by its reciprocal, and then we have a constant. So if we clean this up, we get 20 times 2 is 40, divided by 5 is 8, u to the 5 over 2, minus 8 times 2 is 16, or sorry, 20 divided by 2 is 40 divided by 3. Nothing we can do with that. U to the 3 over 2 plus c. And so if we clean that up, u is x plus 1. If I plug that back in, we get 8 u to the 5 over 2 minus 40 over 3 u again. Whoops, sorry. I said u, I meant to write x plus 1. To the 3 over 2 plus c. You could leave it like this, or because you have these powers with over 2 in them, you could change both of these to square roots. You could have 8 square root x plus 1 to the 5th minus 40 over 3 square root x plus 1 to the 3rd plus c. I believe that's what the workbook does. But anyway, this is an integral that is pretty much undoable in the original form, but doing a substitution allows us to get something that's a little bit more tractable. It's not the usual thing where we have an expression and its derivative, but it's still something that you can deal with using a substitution. So anytime you're doing an integral and you've gotten stuck and can't seem to move forward, trying a substitution is a good way to give yourself some new ideas.